Ο επόμενος καλεσμένος μας έρχεται από το Λονδίνο. Είναι ο Άρθουρ Μάμου και το γραφείο του ειδικεύεται στην ψηφιακά σχεδιασμένη και κατασκευασμένη αρχιτεκτονική. Προσφέρει ακόμα παραμετρικές συμβουλές και σχέδια για το Metaverse. Στόχος του είναι να δημιουργεί βιώσιμη αρχιτεκτονική, η οποία δεν κάνει μόνο καλό στον πλανήτη, αλλά διαγείρει άμεσα την περιέργεια και το δέος. Στη σκηνή μαζί του θα βρεθεί ο Ηλίας Μεσίνας, αρχιτέκτονας, πολεοδόμος, σύμβουλος περιβάλλοντος και ειδικός στη δημόσια διαβούλευση και δημιουργός της EcoWeek. Μετά το keynote με θέμα Eco-Parametric Architecture, θα καταδυθούν στη βιώσιμη πόλη με μια συζήτηση.
Hello. I don't know if you... Can you hear me? Yes, brilliant. I liked what I heard. We have to talk about the future before it's too late. That was really nice. So I'm going to speak a little bit about the future, maybe, but more importantly, nature. Parametric design, I'm sure you heard that term. I heard a lot today, form follows function. But when you think of nature, it's more systems, not forms, interrelated systems that follows parameters. Parameter like the sun, like structure. And in a sense, I'm going to speak about that and the idea of circularity. So I love circles. You'll see a lot of projects that are circular. These are projects from Burning Man. I don't know if... Has anyone been to Burning Man in the audience? No? Okay. I'll bring you there, at least in spirit. It's an experimental city in the US, in Nevada, where 70,000 people come together and create a city and then uncreate it. They leave no trace. It's one of the principles. And it will be an interesting exercise. I brought my students from the university to build structures there. In parallel, I'd like to take you to the material world. We have a fabrication space where we build with biomaterials, polylactic acid from sugar cane, fermented sugar, and also with clay. We try and explore materials as well as systems. So I have an architecture practice and a fabrication space available to the public. And this is a bit of a yin-yang relationship, which is really helpful because we try and innovate in our little world, and then we try and share that innovation with the people so that they can be empowered by it. And so in that sense, having both the ability to design and make with others, and able to work on the things itself, the output of your work, rather than a representation. Like often as architects, we draw things, then we give it to a contractor, and then we're not quite sure, you know, the contractor has its own agenda, and so on and so forth. And so sometimes we break that link, a very, very useful link between design and making. We're going to talk a lot about community, because when you start working with materials, with others, people need to understand what it is that they are creating. And so we have a lovely office of more than, I don't know, we have 33 people now, and they are all able to work with the output of their work. And in that sense, it's forming a community that share their discovery. We have a wiki on which we share all our discoveries. And so we share that, the sense of it's okay to fail. And it's okay to fail and try things. And that freedom, in a sense, is really empowering for everyone. So this is the temple, Galaxia. You'll see Galaxia, Catharsis. Somehow Greece is in all these projects, so I'm happy to be here. There is a really nice quote from Larry Harvey, the founder of Burning Man, who said that communities don't emerge from just goodwill or desire to form community, but from a sense of shared struggle, building something together. And in that sense, you know, there is another really nice quote that I found, you know, that was from Harari, the author of Sapiens, who said that maybe we ended up as civilization not because we wanted to optimize crops and have agriculture, but because we were building temples. I'm sure it resonates here. But it's what happens, and I've witnessed it because we built that temple, a secular temple, a temple in the desert, in which we actually brought people together and form a sense of community, a place where everyone could participate. No spectators is one of the founding elements of Burning Man. So this is Catharsis. It's another project that we built, and rather than burn it, as per many projects at Burning Man, unfortunately, we wanted to disassemble it and create a dialogue between cities. And so Catharsis is on flatbed trucks. It's a traveling architecture that we can assemble and disassemble. The notion of assembly and disassembly is very contrary to, ruins that would last forever. And it's interesting to say it here, but in a way, nature does not stay forever. Nature is an evolving organism, an evolving system that actually disappears. There is death, there is rebirth. And yet our skyscrapers somehow are, someone mentions the ego of an architect. We try and think of permanence all the time. And often we build skyscrapers that end up being empty. What if our buildings could be unbuilt? What if we thought of a choreography of construction and of deconstruction? So in that sense, this is a project we did with Arab, the engineer, where we try and build a crane that would assemble and disassemble a project based on the needs, and it's okay if things are not there anymore. It's the system that matters. So just taking you through the projects that we're working on, this is a project where rather than start from the curve, so of course when we're in front of the computer, you can do all kinds of stuff, so it's exciting. And I think the early days of computer parametric design, we were tempted to do crazy geometries. But what happens if you take the constraints of local craftsmen, local materials, and then you bring them back into the computer, and then you use that intelligence to inform what you're doing, rather than imposing stuff to the people that build. And I think that's extremely important because it makes you think backward, it makes you humble. And ultimately, if you're humble, you might learn more, and you might be more into listening rather than imposing. So this project is basically a reflection of trying to see what a plank of wood wants to some extent. And when you cut trees, the trunk is more or less straight. And there is a convention that pieces of wood should be, unfortunately in inches, but 2 by 4, 4 by 4, and there is a kind of convention around that material that is here for a reason. And so we start from the straight segment, put them in the steam bending, and then bend them to the curvature that is required by the space. And so this was a space for Orange Telecommunication. I'll show you a few parts of that headquarters we worked on. And basically, those are all made from straight pieces of timber. And then we fractalize it. So we continue the same technique on a smaller scale. And on a smaller scale, just like you'll reproduce that in nature, you'll see in a leaf, the system overall is often the one you'll find at a smaller scale. Similarly, this is a sheet of plywood. Plywood is layers of wood that are glued together at different angles, just like cross-laminated timber, but at much thinner scale. It's an off-the-shelf piece. We use lasers to form these springs, like springs that can be bent. And so we form 3D from 2D, just like origamis. The beauty of that is that it's flat pack, so you can travel not air. Often when you ship things, it's mostly air because it's forms that are already formed, but you ship flat elements, and then the 3 dimensions happen from creating what's called bend-active movement. So we bend them, and they want to unbend, but we hold them from the back. And so this has become a project that, in a way, became a product. And that's been really great, because that means we can learn from it and improve it. And it helps us a lot to not have to reinvent everything all the time. I think that's another problem with us architects, is we reinvent everything all the time. And these are variations. This is at Fortnum and Mason, the bar in the famous shop in Piccadilly Circus in London. And the base pieces here are made from PLA, fermented sugar, mixed with wood. I'll speak a lot about this, but just to show you the kind of transition from these different materials. Similarly, from 2D to 3D, this is a giant origami that we did for the headquarters of Orange in Paris. These are made from 0.8 millimeter thick zinc and steel combination. The idea is that on their own, those pieces would be very flimsy, very weak, but together, folded, they're actually really strong. And I think there's a beautiful, almost poetic aspect to that you'll find also in other projects, which is systems are about the interconnection. This is what makes it strong. It's not about using a fancy material or a beautiful form. It's about letting the system form the strength rather than the form. Talking about circularity, this project is now being built in Bali. And rather than, kind of design in vacuum, what the client did was exceptional, is he found a bridge, an old colonial bridge, that he bought. It was unused. It was made of Ulin timber. It's iron timber, so it's a very, very dense. And this bridge is 300 years old. And it was deconstructed. We shaved off all the pieces of iron and the nails, and then the entire tower was rebuilt from it. And so it's nice to think, what do I have access to before I build? What do I need to cut? Do I need to mine? Do I need to grow? Or can I reuse, And that's also a bit of a shift, right? We again, tend to design without asking ourselves the question of that sort of context, not just the urban context, but the material context. And so that tower is built from that material, and then the skin is built from rattan. So the curved, the gentle element is made from a much thinner, locally sourced material. So talking about empowering, I promised to take you then to Burning Man. We built this project recently from using augmented reality. So in augmented reality, these are HoloLens goggles, you can see a three-dimensional thing. But instead of being in a virtual reality, you're seeing the reality in front of you. So what happens is you can use really cheap material, off-the-shelf cheap material, like in this case rebars, the one we use for reinforcing concrete, and shape them into any form that the augmented reality might tell you. And so you can therefore have people that are not necessarily trained in metal work do projects like this. And so in that sense, it's really refreshing because you don't need to use a fancy 3D printer or a fancy machine. You can actually use augmented reality to augment your capacity of building with off-the-shelf traditional material. Saying this, I'll bring you to 3D printing. I was lucky, I guess, to be at the very early stage of when 3D printers were democratized and made open source. And so I was working on assembling my own printers, and then this is a universal language called G-code, for general code, which is what you send to the machines. Whether it's a 3D printer, a CNC machine, you just send simple speed, X, Y, Z information. And in that sense, if you're just sending the pure information that the 3D printers want, then you're not imposing a form to the 3D printer. You're actually working with the language of the machines. I think we get increasingly scared of machines, and only when you speak or when you understand them deeply can you actually, quote unquote, really work with the machine, work with the algorithm, The other great thing when you start working with the inner kind of code of the machine is that you can develop an aesthetic a craft around that machine. So this is, for example, a stool that we're developing with the fermented sugar mixed with wood. And what you're seeing is like almost like a mandala, the idea that from a continuous thread, you can form these geometries. And we do this not just because we find it beautiful, but because it's one way to span in midair and to create strength. Parametric design is wonderful. I love it, because you can change things whilst keeping the same DNA. So from a stool to a table to a house you can use similar inner code and change that. And that's actually really empowering for others because they can be part of this changing of parameters. And then if you have the ability, I would love to bring a fab up here, but we can crush it. So if you can print something, then crush it, then bring it back again, reprint it, then there is this ability to create a full cycle where people are not just buying. You buy a chair, you buy things that are finished. You're not involved in the making. You don't know what to do afterwards. And what if we close that loop? What if we had spaces where we could think in such a circular way, where you're part of the making and part of the end and the beginning of materials? So we applied this idea on our project. This is at the Design Museum in London. It was a piece done from off-the-shelf pieces, from scaffold, pole, and 3D printed panels. And it's been reconstructed already. And the more modular you think, the more you can reconstruct, which is a really kind of unusual way to think. What could my building be if it wasn't that building? And luckily, some tools start to integrate carbon as one of the parameters that you deal with. So this is with Katia. It has carbon as one of the outputs of your digital model. There's a really deep disconnection between the financial cost of things and the environmental costs of things. And so if you can have access to that, those values, you can bridge that gap. Similarly, by using geometry, you can reduce the amount of material. So by creating curvature, you can form shell behavior and therefore use a lot less material than needed. So I see time flying, so I get quite passionate about things. Modularity enables you to create something that's unfinished and that people will finish with their imagination. And that is also something that I find I keep on saying the word empowering. I'm trying to find another one. But what it does is that people can finish it off in their brain, or they can think of different variations from it. So the shop of the future, in a way, the places where you, quote unquote, consume now, could be places where you can realize that you can change things. So we had a shop in which people could use the 3D printers to create. This is a very large project we worked on with this idea of bricks, bio-bricks, that were assembled into creating a three-dimensional shape that is quote-unquote unfinished. It was made from flat pieces that were assembled together. Now, it's strange, it's using a 3D printer as a laser cutter to some extent, but it's a lot faster to print flat and then assemble into pieces. We used that concept. This was in Edinburgh to create a chandelier that was made from flat pieces, 3D printed, and assembled radially. Now, it's not always sugar. We started from sugar for a project in the Middle East and realized there wasn't much sugar there. And so we switched to sand. Now, sand with a certain resin can actually be 3D printed into three-dimensional structure. It's a very different approach, but you can see the idea of modularity coming back into the project. And we're going to build a very large project soon. This is the first time I show it, but which will always also be built with something really interesting, which is what we call a mobile factory. A mobile factory that goes on site and start printing on site. Now, this is the ultimate for us, because that's the idea of having your factory where you are going to make things, reducing the shipment altogether. All right, I promise you to go to the desert, and so I'll go there. I'll do my best. So Burning Man has 10 principles, and I'm sure you'll see all these principles in the work I showed you. Maybe the most important ones, the idea of communal effort, which create community, and also leaving no trace. The idea was to create a city around art, rather than a city where art just happens, and that everyone would be the artist, which is a strange concept, because you go to quote-unquote festivals, and you see who's playing, and then you kind of stand there, you might dance, but you're not composing the art apart from your dancing. Burning Man pushes you to think this way. You build a village of artists, you build a structure, you fundraise from it, you become the entrepreneur, you have to think of the price of everything, so you have to use off-the-shelf material, you have to think of the nighttime interaction, the daytime interaction, and so this is how we came across the idea of building a temple. Now, at the time of doing this project with the students, I was working on something for Virgin Galactic, for the astronauts going to space. And this was a very kind of initial thought about computer science when I was learning it. My dad was a computer scientist, a very early stage, and he was telling me that you can do recursion, which is when you move things around. Let's say you move a vector, and then that vector is then moving again on its own, on its own, on its own. And this is what generates these geometries that can be grown in certain ways to follow the sun, for example, leaving the sun coming in, the sunlight coming in during winter and diffusing it in the summer. So this led to this hotel that never happened because, fortunately, Virgin Galactic couldn't. And then it led to Galaxia. So Galaxia was a temple that is meant to be universal because it didn't have a religion associated to it. And it was 20 gateways that started from the human scale and then pushed you to a communal space in the middle. That project, 60 meters wide, 20 meters high, built with 200 volunteers, all self-funded, as in, we had to find $600,000, which was not an easy task, but pushed me to think of every single use of material, any optimization. So there's no columns, it's all structure. Everything works together as a system. And that means we can use off-the-shelf timber, we can use off-the-shelf screws, and then we keep it together. Instead of heavy foundation, everything is on cables. There's a bike wheel in the middle that holds it all together like that. And so everything is working, and we try and maximize tension. Tension is so much lighter than compression. And the more tension you have, the lighter the structure can be. It's like a giant tent. This was how we built it. Started from the one-dimensional members, to the triangle, to the volume, folded into these bricks. These bricks were then formed into 400 of these drawings that were then passed on to volunteers for them to fold them and assemble them together. The engineer gave us a really simple formula. If you really want to use the number of screws you need, this is what a screw can take, and that's the newtons. Deal with it. So we just knew that, so we used the exact amount of screw we needed, which is, obviously, you need a certain kind of add-on to that, a margin. But what happens in architecture now, because of modernism, where we just copy-pasted the system, we just didn't bespoke our systems to the needs. And so therefore, we just wasted. But if you could use the right amount of screws just based on using, parametric design and a laser cutter, you can be so specific. And that's what 3D printing, digital fabrication in general can enable. Yes, so we closed them into these giant bricks. We obviously had many volunteers to push them into these portals and put them together into that assembly. We then removed the scaffold, and the whole structure settled on its own until other people, the community, entered and started building all kinds of stuff within that structure. It was beautiful. I got married in there, had to, I was so stressed about it, so it was nice to finally use it as a temple. We let it live for a week, and then we burnt it. We had to. It's the ritual. It's in the name. 70,000 people quietly seeing all of their offerings being burnt, letting go. A lesson in letting go. And we cleaned it. We recycled all the steel. We had to leave 0 trace. And so just to finish, we wanted to go back. We didn't want to burn anything. We wanted things to travel. We wanted to include others. We wanted to create a dialogue. I heard Agoras, I'm here in Greece, so it's special to speak about catharsis, because this is the place where you can reinvent yourself. Now, it's based on a fractal, which is a bit of an agora made of agoras. It's a fractal circle made of circles. It's called the Poincaré disc. And I thought it would be interesting, because if there's no spectator, how do you create an amphitheater with no spectators? If not by creating a fractal amphitheater. It was really wonderful, because all these galleries for exploration and these main circles for witnessing art. And it was the perfect opposite of the temple. It was in the city, it was noisy, people could get married without being kicked out. I was kicked out of my own wedding, because people were quietly mourning, So we could do the opposite. We had Refik Anadol do beautiful projection mapping. People would positively vandalize it, and then we took it down. We took it down, and then it was going to be built back in London, and then it didn't work out. So it's still on storage, which makes me sad, but also makes me realize, people are not quite used to this approach. You can place it anywhere, virtually. This structure has lived in the metaverse. You can, use the Instagram and put it in augmented reality anywhere. But ultimately, we need to rebuild it. And so, structures as system, just to conclude, enable you to think beyond just the form. And I think that's a really important part, especially as we enter the AI age, where you type a few words and you see things happening, and people just sort of blame the AI or just say, oh, it's going to take over. These are sketches that are parametric, but they're just sketches that I do. Because it's a way of thinking. It's not just about knowing the software. And then I put all my projects in the AI and see what the AI does, and then get inspired and sketch again, creating a circle, an empowering circle, not a means to lose control, but a means to let go of your own ego. Thank you very much.